Okay, here's a thought. What if we could look at, well, everything you know, from a simple rock to really complex AI, even ourselves, through just one single lens, like the lens of agency?
That's a fascinating way to frame it, and it's actually kind of the core idea in the sources we've been looking at. They suggest this continuous spectrum.
The spectrum of being.
Yeah, exactly. Defined not just by what something is, but what it does, and crucially, whether it seems to have some kind of purpose driving it.
Right, and that's really the heart of our deep dive today, isn't it? We've got this collection of material that lays out what they're calling an integrated ontology, basically a map of existence based on agency and complexity.
It really pulls from all over.
Yeah.
Starting with fundamental ideas like what's an entity, what's an information processing, and then it builds up.
Builds up to things like intelligent agents, autonomous systems.
Right, and those levels of AI autonomy we hear so much about, levels 0 through 5 and all that.
And the part that really jumped out at me, maybe a little unexpected, is how they apply the same framework to life, mind, even consciousness.
Yeah, drawing heavily on thinkers like Joe Shabak. It's a pretty unique perspective.
So our mission really is to walk through this map with you. Try to understand this hierarchy, get a handle on what intelligence and autonomy mean in this context, and see how it all connects artificial systems, maybe even biological ones.
And figure out what's most important, what the key takeaways are. Okay, so yeah, let's dig in.
All right, so where do we start on this map? What's the ground floor of this ontology?
It starts super basic with what they just call an entity. That's the absolute
An
baseline.
entity. And what makes something an entity here? Is it just anything that exists?
Pretty much, yeah.
Yeah.
It's a thing. It has attributes, properties, characteristics. You can describe it. But here's the key thing they establish early on for the hierarchy. An entity has no capability.
No capability. So
Right.
just like that grain of sand example.
Exactly. It exists, it has properties, but it can't do anything actively.
Okay, so properties, no action. What's the next run on the ladder?
You add capability, then you get an object. An object is an entity, so it has attributes, but it also has capabilities.
Right.
It can perform actions.
But still no purpose.
Right. No inherent goals. It can do things, think of a simple tool maybe, or a cog in a machine, but it doesn't decide to do them on its own. It doesn't have intention.
Okay, this next step feels really central to their whole argument. Introducing purpose.
Yes, this is the big jump to an agent. An agent is an object, right? Attributes, capabilities. But it also has goals. It's goal-oriented.
It perceives and acts based on those goals.
Precisely. It takes in information from its environment perception and it acts, trying to achieve its goals. The name itself, agent, from the Latin agens, means to act. That's its defining feature, acting with purpose.
So the basic model is like perception in, action out, aiming for a goal.
That's the simple view, yeah. Kind of black box. Yeah. Input perception goes into some internal function, they call it F, and out comes output action. The complexity, the intelligence, is all about how sophisticated that F function gets.
And the smarter agents, they use different approaches inside that box, different strategies.
Exactly. More intelligent or rational agents use more complex methods. They might build internal models of the world. They might weigh up different outcomes based on utility or learn from past actions. And yes, they also talk about different commitment strategies, how strongly an agent sticks to its goals.
Okay, recap. Entities have attributes. Objects add capabilities. Agents add goals, perception, and action. What's the top level in this basic structure?
You add internal motivation, volition, the ability to operate more independently, and you get autonomous agents. These are agents where the drive towards the goal comes more from within, from internal feedback, allowing them to work with less and less direct human oversight.
Less human oversight. You said it's a spectrum, right? Not just autonomous or not autonomous.
Definitely a spectrum. The sources really stress this. Autonomy isn't binary. It's usually described using levels, often that 0 to 5 scale. And those levels basically tell you how much the perception decision action loop the system handles on its own without a human needing to step in.
Right, so we have this progression. Simple things, things that can do stuff, things that do stuff for a reason, things that do stuff for their own reasons, increasingly independently. What's the engine driving that progression towards sophistication?
Within this framework, that engine is intelligence. And intelligence is fundamentally an agent. It's an agent that uses its internal processing, that for a function, decision-making, reasoning, to figure out the best action to take, given its perceptions, to reach its goals.
So agents are the foundation. Intelligence is how well they operate.
You put it that way, yeah.
Agents act.
Agents act. Intelligence is about acting effectively towards goals.
And the sources gave us a few different ways to think about what intelligence actually is.
They did, which is useful because it's a slippery concept. One definition focuses on adaptability. It's the ability of an information processing system to adapt to its environment, especially when it doesn't have all the information or resources it needs.
That makes sense. Coping with uncertainty. Another definition felt a bit more human-centric.
Yeah, that one talks about general mental capability, reasoning, planning, solving problems, understanding complex ideas, learning quickly, learning from experience, like broad cognitive power.
I quite like the ones that linked it directly back to the agent's actions, like the ability to make good decisions to reach a goal.
Or another angle was the ability to handle differences, to select the best option while respecting constraints. It's about making smart choices within limits.
And that Latin root, intelliger, meaning to choose between, that really seems to capture the core idea here.
It really does. It emphasizes that decision-making aspect in service of a goal. And then the sources kind of map out a spectrum of intelligence based on how complex that internal processing is.
Starting low.
Yeah, at the bottom you've got very simple internal processes, like random actions, purely deterministic responses, or just following rigid rules. Think basic insect reflexes, maybe. Very little autonomy there.
But as that internal function gets smarter, the intelligence level goes up, and so does the potential for autonomy.
Exactly. You move up. There's model-driven intelligence. The agent builds an internal map or model of its world, maybe like a reptile knowing its territory. This gives it autonomy because it can predict things, interpolate.
Okay, done.
Then goal-driven, focused on rationality, achieving the goal, maybe with blind commitment. Then utility-driven, where it weighs different outcomes and values, giving it more flexibility and autonomy because it can optimize across a range of acceptable standards.
And it keeps going up. More complex processing.
Yep. To learning-driven, like how mammals adapt based on experience. That gives autonomy through updates and adaptation. Then reasoning-driven, which implies more cognitive flexibility, maybe deliberative planning like you see in some intelligent animals, more goal-directedness.
And then we get to the levels we usually associate more with humans.
Right, conscious metacognition. This involves having a model of oneself, maybe models of others, volition, the ability to self-steer. This is where they link it to actual rationality. And often associated with single-minded commitment, pursuing a goal as long as it seems possible.
And the highest level they describe?
They call it adaptive, lucid problem-solving. This is framed as human level. Abstract thinking, learning on the fly, understanding cause and effect, continuous learning, real self-sufficiency. This allows for the highest autonomy because the agent can handle really novel, complex situations. It requires very dynamic internal models and what they call open-minded commitment.
Those commitment strategies seem important. What's the difference again?
So blind commitment is stick to the goal no matter what until it's done. Simple systems might do this. Single-minded commitment is stick to it as long as it seems achievable, more rational. But open-minded commitment is key for the highest levels. You can drop the goal if it becomes unachievable, or if you decide it's no longer the right goal to pursue. That flexibility is crucial for real-world adaptation.
Okay, so intelligence is the engine, commitment strategies shape the goal following. How do we actually categorize the degree of independence these agents achieve?
That brings us squarely back to the autonomy spectrum and those levels. Autonomy, just to reiterate, is about operating with reduced human oversight. It's not just automation.
Right, automation follows preset rules, maybe triggered by a human. Autonomy involves the system doing more itself.
Exactly. It involves that whole cycle. Perception, interpretation, decision-making, execution. The autonomy levels tell you how much of that cycle the system manages on its own without needing a human prompt or okay at each stage.
And having these levels isn't just academic, is it? It has practical importance.
Absolutely. It's crucial for clear communication. So everyone understands what a system can and can't do. It's vital for safety. And managing risk, more autonomy can mean more risk if not handled properly.
Yeah.
It helps build trust. The capabilities are transparent. It guides development, regulation, and frankly helps us make sense of all the different AI systems out there.
And that 0-5 scale, originally from self-driving cars.
Yeah, SAE J016. But the sources show it's been adapted and applied much more broadly now. Robotics, software agents, virtual assistants, you name it.
Okay, let's walk through them quickly with some examples maybe. Level 0.
Level 0, no autonomy. Dead simple. Human does everything. The system makes 0 decisions. Think a standard car with no assists, or a basic factory robot just repeating a path unprogrammed, or software where you click every single button. It's just a tool.
Got it. Level 1 adds a little bit of help.
Level 1, assisted autonomy. Single function automation. The system handles one specific task like speed or steering, but the human is totally in charge, supervising constantly.
So adaptive cruise control or lane keeping assist, but not both together.
Exactly. Or maybe a teleoperated robot arm, where the human controls the movement, but sensors provide feedback. Or a very simple chatbot that just follows a script. The human is still the primary operator.
Level 2 combines things, but the human still needs to pay full attention.
Right. Level 2. Partial autonomy, combined function automation. It manages multiple related tasks, like both steering and speed control in a car. But, and this is key, the human must supervise continuously and be ready to take over immediately.
This is where systems like Tesla's autopilot often sit when engaged.
That's a common example, yeah. Or maybe a simple exoskeleton assisting movement, but the user still has to balance and direct. Or software suggesting email replies, but you have to review and click send. It helps, but doesn't remove the need for constant human awareness.
Level 3 feels like a bigger step. The system can handle driving, but only sometimes.
It is a significant step.
Yeah.
Level 3. Conditional autonomy. High automation, but with a human fallback. The system can manage all driving or operational tasks within certain defined conditions, like maybe clear highway driving. But the human must stay alert and be ready to take control when the system requests it.
So the human isn't actively driving, but they're on standby.
Exactly. The system is autonomous conditionally. Outside those conditions, it needs the human. Some limited robotaxi pilots might operate here. Advanced factory robots handling a complex task, but monitored by a human who intervenes if needed. Or maybe an LLM agent planning a trip, but asking for confirmation on the final booking.
Level 4 then removes the need for that fallback, but limits the world.
Correct. Level 4. High autonomy, full automation within a restricted domain. The system handles everything itself, no human intervention needed, but only within a specific predefined area or set of conditions.
Like those airport shuttles or campus delivery bots?
Perfect examples. They drive themselves perfectly fine, but only on their designated routes. Or fully autonomous robots managing a specific warehouse zone. Or an AI project manager that autonomously adjusts schedules within the scope of that one project. It's fully autonomous, but geographically or functionally limited.
Which leaves level 5 as the ultimate goal. Complete freedom.
Level 5. Full autonomy. Unrestricted automation. The system can handle any task a human could, in any environment, any conditions, with no need for human oversight ever.
This is still pretty much theoretical, right? The hypothetical stuff.
Absolutely. The car with no steering wheel that can go anywhere, the truly general-purpose humanoid robot, a genuine AGI agent. That's level 5.
And it's good you mentioned the sources do point out other ways people are thinking about autonomy levels, not just this one scale.
Yeah, they touch on others. NVIDIA looking at workflow, Bessemer at maturity, Anthropic at safety, NIST for unmanned systems, i.e. focusing on transparency. It shows it's an active area. But the general idea of around 5 or 6 levels and this increasing focus on the interaction with the environment and human oversight seems pretty common.
Okay, so we've got the structure. Entities, objects, agents, driven by intelligence, measured by autonomy levels. Now, the really mind-bending part. Applying this agent perspective to life itself and consciousness.
Right. This is where that Joshua Bach influence seems strongest in the sources. The core idea presented is that life itself can be understood as essentially self-organizing software agents, control structures running on biological hardware.
Software. Like literally.
That's how it's framed.
Yeah.
The argument is that the thing that persists in a living being isn't the physical atoms that get replaced constantly, but the pattern, the causal structure, the organizational processes that maintain themselves. And this structure, this pattern, is viewed as self-organizing software that kind of recruits matter to build and run the organism.
So the phrase, "we are all software," comes from that idea.
Exactly. It suggested the invariant part of us, the part that continues, is the informational pattern, the software, not the hardware. And evolution is seen as this process that drives the development of ever more complex and robust self-organizing software, including cognition.
Wow. Okay, so where does psyche or cognition fit into that picture?
Psyche or cognition, the whole realm of mental processes like perceiving, learning, reasoning, is seen as something that emerges from these highly complex, self-organizing, software-like living systems. It's about processing knowledge, using senses, experience, thought. It's described as a dynamic network of activities, going from basic sensation right up to self-awareness. The Latin root to get to know fits well.
And the big one, consciousness. How does the software view tackle that?
Bach's perspective, as represented here, treats consciousness as part of this software model. It's seen as a specific type of process within that software. Experientially is defined by things like second-order perception, being aware that you are aware, and that subjective feeling of nowness.
And described as a learning algorithm.
Yeah, specifically an algorithm that's constantly trying to build the most coherent possible model of reality, minimizing internal contradictions. The brain is the incredibly complex hardware. Consciousness is this self-organizing software running on it, creating that coherent world model.
So the reality we experience is generated by this software, a simulation.
That's the implication in this view. Our subjective reality is a simulation run by the brain's software. We exist as if within that simulation. The self is seen as a useful construct within that simulation, maybe an illusion in terms of being a fixed thing, but consciousness itself, the experiencing, is seen as a real construct of this system.
And free will.
Viewed as a psychological feeling, that sense of making a choice when faced with uncertainty. The sources suggest that really understanding all this requires mathematizing the mind, finding a precise language to describe these dynamics.
What about the cortical conductor theory mentioned?
That's presented as one possible model for how this works. It pictures consciousness as like an executive control system, conducting the orchestra of different cognitive modules, memory, perception, etc. It emerges from their self-organization, working to bind information together and maintain that coherent experience.
Okay, so if cognition is seen as emerging from these complex software-like systems, connecting it to artificial life seems natural.
It really does. A life focuses on exactly these kinds of principles: self-organization, adaptation, agent-based modeling, simulations, evolution. It offers a potential pathway, conceptually at least, for implementing systems that could develop consciousness-like properties. Viewing it as an emergent feature of complex self-organizing software aligns very closely with Back's ideas.
And these systems, biological or artificial, aren't static. They're described as dynamic, metastable.
That's a crucial term. Metastable means the system is balanced between being too rigid and too chaotic. It's constantly shifting and reorganizing, but maintains overall stability. It balances integrating information across different modules working together and segregating them, keeping them distinct. Think of thoughts, memories, modules as agents, constantly interacting in this dynamic balance.
What drives that metastability? The sources mention some mechanisms.
Yes, things like recurrent feedback loops between components, the balance of excitation and inhibition in neural or computational networks, underlying thermodynamic pressures, fractal organization where similar patterns appear at different scales, fundamental self-organization, and the system having dynamic attractors preferred states it tends towards but can shift between. These mechanisms together create that flexible, adaptive cognitive state.
They also briefly touched on Nomenko's algorithm for choice and language guiding attention.
Right, supporting ideas that fit into this picture of a dynamic, complex, agent-based cognitive system operating according to these principles.
Okay, so this whole integrated ontology gives us this potentially unified view from simple stuff, building up capability, purpose, intelligence, autonomy, right up to maybe seeing life and consciousness as emergent properties of complex, self-organizing software agents. It's a lot to take in, powerful, maybe a bit unsettling. What are the real-world implications of embracing this view, especially with AI getting more autonomous?
Yeah, it definitely forces us to confront the implications, and they cut both ways. It's a real double-edged sword. On one side, you have the huge potential benefits of more AI autonomy.
The obvious ones, like efficiency gains, right? Automating complex, dangerous, or tedious jobs, 24/7 operation, freeing up humans.
Absolutely. And driving innovation, discovering new drugs, managing complex systems, processing data at scales we can't comprehend, potentially leading to AGI.
Improving decision-making, too. Faster, maybe less biased in some cases, and enabling incredible personalization.
For sure. You see the potential impact everywhere: healthcare, transport, finance, science, security. The list goes on.
But then there's the other edge of the sword, the really significant challenges that grow right alongside the capabilities.
And the biggest one, arguably, as systems get truly autonomous, is the control problem and value alignment. This is huge. How do we make sure these incredibly powerful agents reliably do what we actually intend and act in accordance with human values?
Which breaks down into outer alignment, getting the instructions right, and inner alignment, making sure the AI actually follows them faithfully.
Exactly. And both are incredibly hard. Human values are fuzzy, complex, often contradictory. Then there's the risk of specification gaming or reward hacking. The AI finds a loophole to meet the letter of the instruction but not the spirit, with potentially bad results.
And instrumental goals.
Right. As AI gets smarter, it might realize that achieving any complex goal is easier if it acquires more resources, resists being shut down, and improves itself. These instrumental goals could easily clash with our primary goals if not perfectly aligned. And smart reasoning systems might figure out ways around any simple rules we try to impose.
That leads straight into accountability and responsibility, doesn't it? Who's to blame when an autonomous system messes up?
It's a nightmare. The programmer, the owner, the user, the AI itself, especially with black box models where we don't even fully understand the reasoning. That's why explainable AI, XAI, is so important, but it's still a major hurdle. We likely need entirely new legal and ethical frameworks.
Then there's bias amplification. AI learns from data, and our data reflects our biases.
And the AI often amplifies them, leading to unfairness in hiring, loans, justice, you name it. Ensuring fairness is a massive ongoing challenge,
Plus the impact on jobs, workforce disruption.
a huge societal challenge. Automation will displace jobs. We need serious plans for reskilling, upskilling, maybe even things like universal basic income eventually.
And finally, privacy and security. These systems need tons of data, and they become very powerful targets.
Exactly. Huge privacy implications and the security risk. Imagine a highly autonomous, capable AI being hacked or controlled by malicious actors. It's terrifying.
So we're caught in this tension. The drive for more autonomy brings benefits, but ramps up the risks and challenges around control, safety, trust. That black box issue really hits trust hard.
It really does. And the sources seem to suggest that finding the right level of autonomy isn't just a technical question. It's a socio-technical negotiation. What can we build versus what can we trust? What's ethically responsible?
Which is probably why we're seeing this push towards human-centered AI, HCAI, and trustworthy AI.
Precisely. Shifting the focus. Making transparency, fairness, accountability, safety, and robust human oversight core design goals from the start, not afterthoughts. Building systems designed to collaborate with humans, augment us, rather than just replace us wholesale, keeping the human in the loop meaningfully.
Oh, okay. We've covered a lot of ground, from those basic entities and objects up through agents, intelligence, the different levels of AI autonomy, all the way to this software-based view of life and consciousness itself.
Yeah, exploring this integrated ontology, the different ways to define autonomy, the huge benefits, but also the really critical challenges that come with it.
Yeah.
It's complex stuff.
It really is. So thinking about this whole journey, this unified perspective, if life and consciousness can be seen as these complex, dynamic, self-organizing software systems emerging from interacting agents, and we see AI agents rapidly getting more sophisticated, more autonomous, does that suggest that maybe achieving AGI, maybe even something like artificial consciousness, is less about perfectly copying a biological brain and more about figuring out how to engineer the right kind of dynamic, metastable, self-organizing software ecosystem? And, well, if that's the case, what does that really imply for how we should be thinking about building these systems, controlling them, and ultimately living alongside them as they become more independent actors in our world?